Good morning or afternoon, people. Today we are going to begin with the introduction to Lewis structures, and we're going to look at this primarily through covalent compounds. All right, this is going to be a little video to help out my students, reinforce what we did in class, or if you just need a little extra help with this. So first things first, you need to know how to draw a Lewis structure for a single element. Now this is like a really basic explanation for it. All right, these are also called electron dot diagrams if you heard it that way. It's just I'm used to calling it Lewis structure from the old school. All right, so the very first thing that you do is you write down the symbol. Our example over here on the right hand side is oxygen. All right, so the symbol for oxygen is O. All right, the next step is we're going to count the number of valence electrons. So oxygen is right there. It has 6 valence electrons. Okay. Now, rule number 3 gets a little bit more in depth. It says start in one direction and place a dot to represent the valence electron. Okay, well, we have 4 basic directions, right? North, south, east, and west. So we're just going to start in one of these directions and place a dot that represents a valence electron. So I'm going to put one right here. Okay. Well, rule 4 says keep going from direction to direction until you have to double up. Okay, so I'm going to place 1, 2, 3, 4. Okay, now I'm going to double up. Okay, I'm going to keep going now from direction to direction until I run out. 5, 6. Okay, so there we go. Rule 5 says the dots can never be more than 8, so if you have a lot, then you are wrong. Okay, the number of dots should equal the number of valence electrons. And I want to pinpoint a couple things right here. First of all, please note that these are 2 electrons in the same direction. All right, they are paired up. However, this little guy right here is a lone pair. These lone pairs are important spots because we know when we draw out Lewis structures for compounds that this is going to be like an activity site, a bonding site. Okay? All right, so that is how you draw a Lewis structure for a single element. Let's go ahead and try it for a couple more examples. Okay, so for calcium, calcium is over here in group 2. So it has 2 valence electrons. Okay, so what I'm going to do is I'm going to start in one direction, and I'm going to go around to each direction until I run out or have to double up. So 1, 2. All right, please note that this is the right answer right here. Placing this dot in this direction so I would have 2 in the same direction would be wrong. Okay, so we leave them exactly how you put them originally. This is correct. 1 in the north, 1 in the east. Okay, they are both lone electrons. Okay, now let's look at fluorine. Fluorine is over here in group 7, so it has 7 valence electrons. So we got a lot more dots to draw. So I'm going to start in the north. I'm going to go 1, 2, 3, 4, 5, 6, 7. So I had to double up some. All right, I got 3 paired up electrons and 1 lone electron. Okay, I have 7 dots. I have 7 valence electrons. I know I'm good to go. All right, so that's just like a beginner step. All right, this leads us into covalent Lewis structures. All right, and so this is going to be the little electron dot diagrams for each element and how they bond. Okay. The second thing you need to know about this is a line, like this right here, represents 2 electrons. These electrons are in a line because it shows that it's being shared between the 2 elements. So this line between the hydrogen and the oxygen represents there's a dot right there and a dot right there being shared amongst the H and the O. Okay, and another thing that I could have is I could have a single bond, a double bond, and even a triple bond between elements. Now remember, covalent Lewis structures are between covalent bonds, which means it is just nonmetals. So I went ahead and made these simple rules to follow. Now it looks like a lot, these 4 rules. It involves like a little bit of math, a little tiny math. But if you follow these steps, it is a guide to help you know how many lines to put and how many free electrons to put. All right, this is going to be like a shortcut and a way to double check your answer. Okay, so we're going to go ahead and do HCN together. Okay, and we're going to follow these steps, and I'm going to work through them with you so you could, learn how to do Lewis structures for covalent compounds. So rule number 1, okay, it says how many valence electrons does the compound want to be happy? All right, so we're going to add up the total amount of electrons each element wants for the whole compound. So we got H, okay, and according to our, like the octet rule, we know that H, it doesn't want 8. It wants 2 in its outer shell. Carbon, all right, it has 4 valence electrons, but it wants a full outer shell, so it wants 8. And then nitrogen, the same thing. It also wants 8. So for each element, the answer is going to be 8, except for hydrogen and helium. But since helium's not really making any bonds here, you just ignore it and it's just for hydrogen. So we get a total of 18 right there. Okay, let's look at rule number 2. Rule number 2 says, how many valence electrons does the compound have? So in this case, we're going to add up the valence electrons for each atom. We got H, we got C, and we got N. All right, so H has 1. I can look on my periodic table, and carbon is in group 4, so it is 4 valence electrons. And then nitrogen is in group 5, so it has 5 valence electrons. I add these up, and what do I get? I get 10 electrons. All right, that's how many valence electrons this has. Okay. My third step says how many are missing. So if I want 18 electrons and I only have 10 available, then I am missing 8 electrons. That's what's keeping this compound from being happy. And that's why it's making bonds. It's going to share electrons so it could get those 8 electrons in its outer shell. I mean, that's why everything bonds, right? Is to have a full outer shell. Okay, so number 4 says, how many bonds do I need? Well, if each line, which shows a bond, is representing 2 electrons, then we just divide this by 2, and we get 4 bonds. I need to draw 4 lines, okay? Okay, so if I got an H, I got a C, and I got an N. Okay, well, in this case, we need to figure out, what am I going to do? Can I make a triangle? Is one going to be in the middle? All right. Is it going to be a straight line? And let's just go ahead and assume that carbon is in the middle. And it's a good thing to know that carbon is pretty much always in the middle. All right, it has 4 bonding sites that it could accept, so it likes being there. So let's go put carbon right there. And we can put hydrogen and nitrogen pretty much anywhere right now because we haven't learned Vesper theory or what kind of angles, so you just put them right there. Okay, so we're going to draw 4 lines. So if I put 2 lines right here, okay, I've connected everything, but I still need to draw 4 lines total. So can I put lines like that? Can I have bonds going nowhere? No, I gotta put them somewhere. Can I have a line going to hydrogen? Well, no, because if we think about it, this hydrogen, all right, this guy right here, he's now sharing 2 electrons. All right, so he's already happy. He's done. He doesn't want anymore. So we're not going to put those lines there. We have to put the lines to something that could still accept it. So we're going to put the 2 other lines right here. All right, so now we need to go back and just fill in any lone pairs, any pairs that are not bonded. Okay, let's make sure everybody is happy. And whoever is not happy or who doesn't have a full outer shell or meets the octet rule, we're going to put those dots to represent the electrons. Okay, so let's take a look. So hydrogen, he's got his 2 right there. He's happy. Let's take a look at carbon. All right, carbon's got 2, 4, 6, 8. So carbon is happy because each line represents 2, right? Okay, so now let's look at nitrogen. Nitrogen has 2, 4, 6. So he's missing 2 valence electrons. So we're just going to put them right there. Okay, and now he has 8. He has 8 and he is happy. All right, now you're probably wondering, okay, how do I know that this is a correct, I got the correct number of everything? Okay, well, here's the little trick, all right, to make sure that everything matches up. Your answer should match number 2. Okay, I should have 2 valence electrons for hydrogen, 8 for carbon, 8 for nitrogen, but through bonding, it should only equal to 10 electrons. Let's see. I got 2, I got 4, I got 6, I got 8, I got 9, and I got 10. What do you know? This was a correct answer after all. All right, so that's how that's done. All right, this is, sure, it takes a long time on doing this method, but when you get to really long compounds, all right, this guy's gonna steer you in the right direction. Let's see if we could do another example. All right, so here's a really simple one, a diatomic compound. All right, chlorine. There are 2 chlorines. We could fly through these steps right here. Okay, so step number 1, how many valence electrons does the compound want to be happy? Well, each chlorine wants 8, right? So that means it wants 16. All right, step number 2, how many valence electrons does each one have? If I look at the periodic table, I see that each chlorine has 7 valence electrons. That equals 14. Okay, step number 3, how many are missing? I just subtracted 2. Okay, so that's 2 electrons are now missing. I have to make a bond to share 2 electrons. All right, so step number 4 says how many bonds are needed. I just take the answer for number 3, divide it by 2, so it means 1 bond is all I need to draw. So if I have chlorine and chlorine, note with just 2 elements, nothing is in the middle, and I need to draw 1 bond. All right, can I leave it like this, though? Is this the right answer? All right, let's see if anybody's happy. Well, this chlorine only has 2. Nope, no one's happy at this point. All right, so now we got to go through and make sure we have enough dots to everybody be happy. It will equal that number. Say each chlorine is already sharing 2 electrons, so I'm just going to add in 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. Now is everybody happy? Does everybody have 8 electrons? 2, 4, 6, 8. All right, so that guy is perfectly fine. 2, 4, 6, 8. Okay, he is perfectly fine. And if I count everything up, then I got 2, 4, 6, 8, 10, 12, 14 dots represented. Yes, this is the correct answer. Let's go on to another one. Okay, this one is going to be a tough one, so let's see if we could do it. We have a grand total of 4 electrons now. 4 elements. Okay, let's see if we can follow our rules and work through this. Okay, so rule number 1, how many valence electrons does the compound want to be happy? Remember that is 8 for anything that's not hydrogen. Hydrogen wants 2 each. There are 2 of them. And then, of course, oxygen wants 8. If you get confused, you could kind of put like a little title above them for each column to represent, okay, that was with the carbon, that's with the hydrogen, that's with the hydrogen, and this is with the oxygen. Okay, remember it's 8 for each element except for hydrogen that wants 2. That's how you meet the octet rule there. All right, number 2 says how many valence electrons does the compound have? We look at the periodic table. We know that carbon has 4 because it's in group 4. Hydrogen has 1 each. And then if you look at the periodic table, all right, oxygen then has 6 valence electrons. Okay, so I'm going to add these up because I haven't added them up so far. That is 20. All right, for number 2, it is 12. Okay. Step 3 says, how many am I missing? Well, I have to subtract these, and what I get is 8 electrons are missing. All right, so I have to form bonds to share electrons so I could have the octet rule met. And then for number 4, it says how many bonds are needed. I just divide this by 2. I need to draw 4 lines for 4 bonds. Okay, so we got 4 elements in this compound. Somebody's got to be in the middle. All right, we already had said that carbon pretty much wants to be in the middle, so you could put the O's and the H's anywhere at this point because, like I said, we haven't gone over Vesper theory, or maybe you're not worried about Vesper theory and you're just worried about drawing, so let's go ahead. All right, so we got to draw 4 lines. Well, we know the hydrogen could only deal with 1 line, right? He only wants 2 electrons. And if each line represents 2 shared, then he only gets a line. He doesn't need any more. So where are we going to put the other 2 lines? Well, the only places it can go, in between the C and the O. Okay, now we're probably asking ourselves, what are we going to do from here? All right, is everybody happy? So let's first look at this hydrogen. That hydrogen is happy. He has 2. Okay. That hydrogen is happy. He has 2. What about this carbon? Well, it has 2, 4, 6, 8. He also meets the octet rule, and he is happy. So let's go ahead and take a look at this oxygen. This oxygen has 2, 4 electrons attached to it or shared amongst it. So he is not happy. So what do we need to do? We need to put dots to get him up to 8. So he has 2, 4, 5, 6, 7, 8. Okay, and they're paired up right there. Okay, so now we should be able to go through and see if this is a correct Lewis structure. Just to double check, remember that it's going to meet this number right here. All right, there should be 12 electrons represented by this whole Lewis structure, and we'll see if we're correct. 2, 4, 6, 8, 10, 12. What do you know? We got it right again. All right, we are hitting it 100%. So if you need more help, ask someone, view this video again. But that is basic Lewis structures for covalent compounds. Thank you.